Good afternoon, everyone, and thank you for joining the first pre-conference session of the first annual Eastern Medical Research Conference. I'd like to start by acknowledging the generous support of this sponsor session, which is the American Federation for Medical Research. Without their support, this conference would not be possible. Before we begin, I do want to share some guidance for the session. We ask that you do not copy or record the presentation. The presenters will be available live after the session for Q&A. If you have questions for the presenter, you may ask them by typing into the Zoom Q&A area. As the moderator, I will ask the presenter as many questions as possible at the end of the session. For those of you that are also attending the ESPR AFMR First Annual Eastern Medical Research Conference, you may also wish to contact the presenter directly via the meeting app. You can message them directly through Attendify. You may also access the conference abstracts and schedule at any time within the next year by logging back into the app, or they will be listed on both the ESPR and the AFMR websites. Finally, please do not forget to complete the evaluation at the end of the conference. Your feedback is necessary to make improvements to both our organizations and the annual meeting. So now I would like to introduce our workshop speaker, Dr. Bruce Kronstein. Dr. Kronstein is the Dr. Paul R. Esserman Professor of Medicine in the Department of Medicine, Professor in the Department of Biochemistry and Molecular Pharmacology, and Professor in the Department of Pathology at New York University Grossman School of Medicine. Dr. Kronstein's research has focused on adenosine, and his laboratory was the first to demonstrate the presence and function of adenosine receptors on human polymorphonuclear leukocytes, including their role in regulating inflammation. We are delighted that he will be teaching us all how to successfully turn our research abstracts and posters into research manuscripts. So I will turn it over to you, Dr. Kronstein.
Great, thank you very much, Andrea. I thought this would be better as kind of a conversation, as much as we can make it a conversation on a Zoom call, and not show any slides, because I think that the topic itself is very broad and at the same time very specific. It's very broad because all of you are doing different kinds of science, and it's very specific because changing over from a presentation mode to an actual paper really is many of the elements are mechanical, and so don't really need much discussion. But there are a couple of things that I wanted to note. First, for those of you who attended these sorts of meetings before the recent COVID epidemic, when things were in person, you'll recall that generally speaking, there were these huge halls with rows of posters, and the presenters standing in front of the posters, which gave you an opportunity as either a reviewer or an attendee to wander by and pick the brains of the people who did the work, and at the same time, it was a very social event. You run into old friends, old colleagues, and have an opportunity to have them bring you around to the work that their young colleagues were doing. So that has not been quite as easily done in the Zoom age, and so it's been a little difficult to really make much from an abstract in the social sense. That is, you can't really go to an abstract session and expect to have a side conversation with somebody that you haven't seen in a year, when basically everybody's forced to listen to a single voice. But the other advantage of being able to present your data, your abstract, your presentation at a session directly is that you'll get questions. the people coming before you are they're smart, they're insightful, they're interested, they know something about the area of science that you're doing, and as a consequence, they really can offer you a tremendous amount of help before you've actually sat down to write the paper. So that if somebody asks you, a question which suggests some experiments that you have not done, it's not unlikely that that either that person will be a reviewer of your paper, or that other reviewers won't have the same kind of questions. So listen to the potential reviewers, answer their questions. They most of the time, because they're in person, and we'll be back to that next year, at least according to the slides that introduced us. Those people, in a social situation, they're not that interested in knocking you down or tearing you apart or ruining your burgeoning career, but they actually, they have a scientific interest, and while they may want to tout their own work in the past, they will still offer you something of interest. So keep those criticisms to heart. They're well meant. They are often, I learn a lot from presenting data to other people, because I don't know everything, even though I think I do. And I think that we can always learn from our peers, and our peers, generally speaking, are an okay. They're benign. They're on your side. Nobody's really out to tear you apart. When you get to my stage, then they're more interested in tearing you apart. They get more points for that. But at any rate, we do have, once you've taken those criticisms in, and you've gone back and done appropriate experiments, or you have added something to your discussion as to why you didn't, why you thought about this and either haven't done it, or that this may be the next step in your experimental plan. That's, you'll keep those things in mind. And then the work comes. You have to sit in front of your word processor and put together a paper. And you kind of know what's going to happen, because the abstract that you've written is, it is frequently more detailed than you have to have for an abstract for a paper. But at the same time, you have to make sure that that you cover everything that you're showing in this paper. So I, generally speaking, for me, it's much easier to start out writing the methods section, because it sort of gets the writing juices flowing, and you've already thought about your data, your results, so and how you've organized it, and the story that you want to tell, so that and in fact, if you've given a presentation, generally speaking, each slide, you have 5 or 6 data slides, and that's about all you're allowed in terms of figures for most journals. You can take those descriptions that you've given by mouth, convert them to scientific language, if you will, and be a little more discursive in your descriptions of the data. And everybody has their own style for writing this, but usually I tend to start with why I did the experiment, what I expected to find out. And then usually the last sentence of the paragraph describing those particular experiments, I would try and draw everything together, because when you've done a 6-panel figure, you really need to summarize what it is that you've shown and state it. So you're basically telling people, and then you're showing people, and then you're telling them again exactly what you've done. I then go back, the introduction, usually kind of right after the results and methods. So the introduction usually is an introduction to the field. What's the gap that you're filling here? What does the field not know about X, Y, or Z, and why is it important that the field knows something about this? And it could, I think introductions have gotten longer over the years. They used to be pretty much one-page double spaced, but now they can be as long as 2 pages, depending upon how much you want to summarize what's in the literature. And then finally, I write the discussion, and usually the first paragraph of the discussion for me is kind of a summary of everything that I've found. My next paragraph is a critique of my data, because nobody knows my data like me. I know where the bodies are hidden, so I can I can come in and write that critique in a way about the specific experiments done, and then after that, several paragraphs expanding upon what the significance of your findings are, so that people know what they mean in relation to the rest of the world's literature in this particular area of science. And again, a lot of people will have a conclusion paragraph. At this point, you've told them everything you're going to tell them. You've shown them everything you're going to show them. You've told them again. And, just a quick take home at the bottom frequently helps. So that's kind of my approach to writing a paper from an abstract or a presentation or a poster. So
Dr. Kronstein, so we do have one question from the audience that I'll read here. And then I also, before I read that, wanted to offer to the audience participants, we can also use the raise hand function. And so audience participants, if you want to raise your hand, we can unmute you, and then you can have the opportunity to ask your questions directly to Dr. Kronstein. But Dr. Kronstein, the question we have is, what is the most common reason for not accepting a manuscript?
So it's uninteresting. In other words, if I used to edit a journal called Inflammation. It's still in existence. I inherited it from Jerry Weissman, who was my mentor. It just got to be overwhelming because it's a quarterly journal, and the number of papers submitted to that particular journal went from about 200 to 300 a year to over 1,000 in the past couple of years. So there are a lot more people out there writing papers. Most of the papers that I rejected out of hand, many of them, the English was so poor that I couldn't understand what they were trying to say. But once you get past that, and you can always hire a writer to help you if English is really a problem for you. But after that, it was, the fact that this was just not a very interesting paper. So we received a lot of papers basically showing that compound X from some herbal medicine did function Y to inflammation, and that was about it. And maybe they would show that it inhibited an NF-kappa B or something, but there was no good reason why it did that. So, and they didn't go any deeper into why this compound would have inhibited this particular inflammatory function. So, in that sense, it was phenomenology. It was nice to know that these compounds do all this stuff, but on the other hand, give me a little meat here. Make it interesting for me to read. That was the primary reason. Other reasons are that you submitted the paper to the wrong journal. So we would get a lot of things about allergy, which just was, particularly once we had as many submissions as we had, it was impossible to include papers devoted to allergy. And then for a while, we would get osteoarthritis papers, and there would be just a flurry of them. And after a while, it just, it was clear that this was taking over the journal, so I had to put a stop to that. But those are the main reasons that it's either so badly written that it's not understandable, it's uninteresting, that is, it's kind of superficial, and it's phenomenological, and and it doesn't fit with the journal's goals.
So to follow up on that, there's another question from the audience. How does an author select the correct journal?
That's a really good question. So, depending upon your area, you can go through on Google and find out what the impact factor is for subspecialty journals, and you probably know these better than I do. But if you think you have a really, really hot finding that this is really going to make a huge difference, it'll say change practice, or it will take the field and point it in a different direction, shoot high. The worst thing that happens is they reject it. It's I think that's probably not, it's probably good to aspire to those bigger impact factor journals, JCI, whatever. And then, with the exception of all those online journals that don't really count, there are a lot of online journals that are sponsored, that are offshoots of major journals. I'm familiar with Arthritis and ACR Open, which is associated with arthritis and rheumatism. Frequently, the authors or the editors will refer you to those open access journals. They're not bad. People get them and they read them. Most of them haven't been around long enough to build up an impact factor, but that if the society, whatever the specialty society is, has given, has put its imprimatur on this open access journal, that it will be around, that and that some people will at least look at the title and the table of contents. Most of the time, I mean, there's such a mass of papers coming in now. We all have filters of one sort or another that will pull out the papers that are sort of most interest to each one of us. But shoot high, and as I said, worst that happens is they tell you no thanks, and then you send it on. If you get a review um, and it's rejected after review, again, this is yet another opportunity for you to take advantage of the better parts of that review. So you'll get your review. When I was in the early stages of my career, we happened to have a house in the woods, and I'd gone out and bought a chainsaw, which was really good for working out the kinks after a really bad review, whether it was a grant or a paper or anything else. But usually there's some really solid nuggets in those reviews that are useful, that will really help you to make the paper that much stronger. Once you get beyond what you think is completely nuts or whatever.
Great. Another attendee asked, do you recommend that people look at exemplar articles from the journal that they are submitting to when they're trying to write their manuscript?
It's not a bad idea. I've never done it. I've always written the paper as I've written it. I try not to be too grandiose in my claims. Again, even if you look at things published in the New England Journal or even Nature or Science, those will the claims won't be that grandiose. Having said that, there are a few journals like Nature and Science that have a peculiar format for their papers, but most journals have a similar format, and just make sure you're writing within that format. Again, the problem with writing something and then submitting it to Science or Nature is that you have to bring it back and pretty much rewrite it once it hasn't been accepted to one of those journals.
Can you give young investigators an idea of how long it might take them to go through the process of turning their abstract into a manuscript?
Yeah, that's a good question. How long will it take? So, if you're a very fast writer, which I am not, it can take you a week. If you just, basically take straight out the abstract, you don't incorporate many comments, and if you can come up with this. And so, excuse me. I think it can take as little as a week. Some people are really prolific and they can write papers very, very quickly. I tend to take longer just because I like to think about it while I'm writing and go away from it for a couple of days here and there. If you get to a point where you think you need to do more experiments, then obviously it depends on the experiments. I mean, if they tell you you need to breed a whole new line of mice for this or something, you might take that with a grain of salt, because that's going to take you a year and a half or 2 years, and you should try and find a different place to send it. But really, there's no. It depends. If you don't have that many changes from what you've just presented, and you've really been thinking about the implications and what to put in the discussion that would interest people and make them want to take it. It doesn't have to take very long at all.
And a follow-up to that is, how do you determine when the abstract is ready to become a manuscript? Such as, how do you know when you have enough data to be able to write that manuscript?
Okay, so this is a tough one. Remember, you're telling a story and you're selling this story. And the story has a beginning, a middle, and an end. And if you've got the beginning, you know why you did the experiments. The middle part is all the evidence that you have accrued that tells you what this means. I think that's you know, if you think you have a full story, present it to your peers, present it to your mentors. We at NYU, for our K recipients, we have sort of writing clubs where they can critique each other, peer critiques. We can also do a studio where if you really want this, we can bring together 4 or 5 or 6 people with at least some understanding and expertise in the area of science, and we can assemble those people pretty quickly, and they can tell you, well, you're really missing this or that or the other. But if you think you have a full story, and if you think your data are strong enough or support strongly enough the whatever the conclusions that you'll be making, that's give it a shot.
Great. One of the attendees also asks, who would you recommend that they recruit to review or critique their manuscript before they submit it to a journal?
So again, the writing clubs can be very useful for that. We have a K to Independence group that meets regularly that has a leader, if you will, a faculty leader, and much of the time is spent critiquing each other's work. Now, again, remember, these people may be coming from completely different areas of science, so that they don't really see the logic here, or they don't understand the implications of certain things that you're doing, but that's okay. Again, that's a pretty good method, and your peers can tell you. Again, another thing to do, and this is to talk to somebody who's fairly senior in the field, get them to read the manuscript and critique it and tell you what they think, and you can make use of that. Most people, they should be happy with an acknowledgement for reading the paper, and it doesn't really qualify you unless their lab does some experiments that you're missing or something, but it doesn't really qualify you for authorship. But find somebody that you trust, that you think will be able to give you good advice, is not too nasty or whatever, and can help you out with taking a look at your paper.
Great. We have a couple kind of nuts and bolts questions. So the first is any advice that you have on making effective figures and tables. So like what you should include in those figures or tables, what you should not include, and then how to prepare an effective legend or title.
So again, this really pretty much depends on your data. If you have data that goes over time, obviously line drawings are fine. The thing that, one of the things that I hate is seeing dose response curves as a series of bars. Because I tend to think of dose response sorts of data as curves, and I expect to see that sigmoid curve when I put it in there. Tables, I think, with the exception of, if you're reporting a clinical series and you have that table that has all of the relevant characteristics of the patients or subjects included. I think that's don't make anything that big. I mean, it's really hard to look at a table just because, if you have 12 rows and 7 columns, it's very difficult to take away much of a message. So remember, the thing you're trying to do is communicate here. You're not trying to put every experiment you've ever done into the paper. What you want to do is you want to communicate. So again, tables with too many numbers, too many columns and rows are impossible to look at, and keep it a relatively small number of columns and rows. Graphs should illustrate the point that you're trying to make. Things that happen over time usually happen as part of a continuum. So even though you're making up all the points between the points that you actually assess things, drawing a line curve is not unreasonable. I think it's common these days it's pretty much standard that when you present means and standard deviations or standard errors, that you do a dot plot, that you include each data point so that people get a sense of where these means and error are coming from. Because if you have, it just makes it easier to look at it and understand that these differences are real or not real, as the case may be. So, and what was the other part of that question?
Just the legend, how to write an effective figure legend.
Figure legends, yeah. Again, that varies from journal to journal, but I usually put a 1 sentence in bold print, basically stating the finding, and X does Y to Z, and then usually a sentence or so as an introduction, and then of the sort of experiments that were done, very briefly, showing our Western blots from whatever, and then usually describe each panel accordingly.
Great. There's another question about, for someone who maybe has never written a discussion section before, how do you incorporate the literature in a way that it enhances your paper?
Yeah, that's a good question. So you don't want it to be too detailed. You want to draw some broad implications, number one. And number two, you want to show that you've actually read the literature in this area and you kind of know what has been published and how your data either differs from or expands upon what was already known, and how you can and basically what difference that makes. So again, I would start with the very first paragraph, which is just it's not a restatement, but it's a summary of the findings. We found that X does something to Y that consistent, or that the following, we explored the following mechanisms by which this could happen, and found evidence to support the following mechanism, and go from there. And then after that, it's you can be grandiose in your claims if you can justify it. Most of us are a little more careful about it. And you can, again, you want to make sure that you are really covering the literature in the area that you're writing in, and that you are responding to holes in what's known. And also, if you know the literature well enough, you kind of know the leaders in the field. It doesn't hurt to add one or two of their papers that you've cited. There's nothing that will bruise an ego more readily than citing the wrong paper. So if you go back through the field, make sure that you that you cite people who are leaders in the field, because they may well be your reviewer.
I'm going to shift the focus a little bit back to kind of selecting a journal. So I'm going to combine a couple of questions regarding like publishing fees. So one is like, is it okay to consider an open access journal that has high publishing fees? And then also, like, do you have any advice of how to avoid those if someone doesn't have a lot of funding to be able to pay those fees?
I have no idea how you avoid those fees. So it's just never come up. And actually, if you look at the publication costs for a standard paper as compared to some of the open access journals, they're not that different. It's maybe, I don't know, just pulling numbers out of the air. It's maybe $3,000, $3,500 to publish in an open access journal, and it's maybe $2,500 or thereabouts to publish in, without making the paper open access. And a lot of journals will, that exist as paper journals, will offer you the opportunity to make the paper open access. I don't know. I don't know that makes that much of a difference. That once it's been published in a regular journal, a paper journal, it will be cited in the PubMed, and that's where people are going to find out about it. Most of the people who are reading this will have access to a library that has an online version. I mean, at this point, you almost never have to go to the library to pull out a journal. You're laughing because you've never done that, right?
Nope.
And you can avoid Xeroxing fees as well. So I think that I don't know that if you're given a choice, that open access does much for you. If you submit directly to an open access journal, though, remember, it's a little bit more expensive, but it's not that much more expensive. Some of these journals have outstanding impact factors, and making your paper open to the world certainly isn't going to hurt. I think for people younger than me, there are a variety of metrics that depend upon how often somebody looks at a paper, how often it's picked up in the news or whatever. And so there are multiple other metrics that are going to vary depending upon which journal it's in. Although, again, you'd be surprised that things published in what you don't think are very good journals can sometimes change a field.
So I have a question about kind of the relationship between grant applications and publications. So it helps to establish a track record by having publications to be able to get that grant. But the journal might ask for the data that you need the grant for in the first place to be able to do the experiments. And so just, do you have any advice of how to handle that?
Take out a loan, take out another mortgage. No, it's really difficult. If somebody's asking you, as I said before, if somebody's asking you to establish an entirely new line of mice, that it may be time to move on to a different journal. And there, if somebody asks you for so many experiments that it's going to take you another year and a half to do this, and it's going to involve a variety of fancy manipulations or things that cost a lot, or reagents that that are rare or uncommon, or access to equipment and procedures that cost a lot of money or may not be easily accessible. Sometimes that you just kind of bite the bullet and go with a different journal. Yes, but if you think about it, a grant isn't for a paper. A grant is for 1 or 2 papers a year for 4 or 5 years, depending on the granting agency. So I think that's your grants shouldn't be simply to complete this paper or to gather the data that you need to complete that particular paper. They should be for expanding, broadening, and establishing your hypothesis, the overall hypothesis of the grant.
You sort of answered this already, but how do you respond to critiques that are not possible for you to address? So let's not say that it's to the extreme that you need to switch journals, but is there a tactful way in your kind of critique response?
Right. Yeah, frequently there are talking points, and then there are things where you have to do experiments. As a reviewer, if I think something really needs, another knockout mouse or something to to complete the story or to make it better, I usually, suggest that this could be in the discussion, for example. And just because I know that you're not going to spend the next year and a half making that mouse for this paper. That's just ridiculous. So some things you can discuss as, yes, we believe that if we do the following 3 things, that the paper would be much stronger, but that our data, show the following 4 things that clearly support our hypothesis.
I'm going to shift focus again. We have a couple kind of research ethics questions. So one is, what type of informed consent is required for publication of a manuscript? Is it implied during an author's submission that they got a universal consent, or do journals have their own consent form requirements?
I think they're more or less, there's I think COPE or something like that, that basically most journals require IRB approval, informed consent from appropriate informed consent from patients, appropriate animal handling and modeling, and and that you're not doing particularly painful procedures, whatever, for animals. So I think all the things that you need at your institution to carry out that research, that's kind of a minimum of what you need. So informed consent, yes, and you should state as approved by the X university IRB, or we did the following procedures to mice, and you should mention the if you had to do it under anesthesia or whatever, in order to satisfy the institutional animal care and use committee, because it's a more appropriate and humane way to do these experiments. So yes, all of that is needed.
So a question about authorship. So how do you effectively or sensitively deal with author ordering and then qualifications for becoming a co-author?
So increasingly journals are providing their criteria for what they think an author should have contributed. And so you can take a look, and at the end of many articles in in various journals, you'll see author number X. Author X was involved in the analysis of the data. Author Y was involved in writing and whatever. So I think that you have to make a substantial contribution to the work in order to claim authorship. And just the fact that it was done in your lab, if you didn't discuss this and somebody came up with the whole thing, that doesn't make you an author. But if you did something and you've discussed it with a bunch of people and they've refined what you've done, and they pointed out other ways to do this, they could be described as having participated in the design of the experiments. So I think that there are pretty much set criteria as to who can be an author in a paper. With respect to who is the first author, the last author, and all of the authors in between, that's something you have to work out with your colleagues, and I would suggest that you do this at the outset of a project, not once the paper's written. So if you are doing most of the work and you're really pushing it along and you're going to write the manuscript, you should be the first author, and you should tell everybody else, I think I should be the first author for the following reasons. And the same for the senior author. I think the order of the authors in between, at least in the biomedical literature, doesn't matter quite as much. I had some mentees for a while who were, at least this was 15 years ago, and I don't know if it stayed the same, but the standard there was the first author was the one who had the greatest investment, who really, maybe it was their idea, they pushed along, they wrote the first draft, and incorporated changes into the manuscript. And then after that, everybody else was alphabetical. That's not generally speaking how we do it. Having said that, again, you should arrange with everybody before you've done the work, or at the outset. You've done some of the work, but you haven't completed the whole thing. You should make sure that everybody is on board with where they are as an author. The hard part for many young investigators is separating themselves from their mentors. And that's particularly difficult if you stay at the same institution. So it's it's a delicate problem. Working with a mentor on both sides is like having a teenager. They're trying to be independent. They're trying to be their own person, and they really need to be their own person, not a reflection of you as a senior author. But as a senior author, you may have contributed the idea, or contributed to the thought that went into designing the entire project. I think that's a very difficult problem, and it's difficult for mentors and mentees to sort this out and to separate in a way that both feel happy about it, as opposed to the, just turning 18 and going off to college, and slamming the door behind you as you walk out the door.
All right. So a question that we have to kind of follow up on that. So is productivity for young investigators. So what's considered good progress? Like 1 paper per year, 2 per year? Is it dependent upon the field?
Depends on the field and the type of research you do. I think if you do epidemiologic research, or you do database kind of, mining, that you will probably write more papers. You can do that. So if somebody is doing bench research where they have to, where they have a single experiment that may take 6 months, it's hard to imagine writing more than 1 or 2 papers a year. But so I think a lot of this depends on the kind of science that you're doing. And so I think it's, at least a first authored paper every year or 2, with the pace increasing over time. And, the middle author papers, where you're a contributor, but you're not first or senior author, are probably less important. And if you have too many of those so that they drown out what you've done, then it's they don't really, people don't pay attention to them. I think rather than think in terms of number of papers, what you want to do as a young investigator is establish an area that's yours. So that when people think of X, they think of you, and because you've now published a few papers that really establish you in the field. If you're publishing a paper here and a paper there and a paper in another place that are about sort of disparate things that are related but not totally related, that's not a good way to build a career. You really want to take hold of an area, call it your own, and be able to and know that the rest of the world recognizes that this is you. So I've told this story before. When I was a very junior investigator, I remember going to when this meeting was when the AFMR used to meet with the ASCI and the AAP, and going to some social event, and everybody had a name tag, and fairly senior investigator that I had seen from afar, I'd never really met him, walked over and said, "Oh, Kronstein, adenosine." And and that's kind of when you've made it, when people recognize that while other people may have written in this field since, you started this field and you still kind of own it. It's your baby.
And to kind of follow up on that thought, do you think people in the field appreciate quality over quantity? Should original manuscripts be prioritized over reviews, case studies, et cetera?
Yes, they definitely, at my level, at the people who are going to be reviewing you for fellowships, or or if you're looking to move and find another position, people are going to go through your CV, and it's very clear. It's really very clear what when you're looking at a CV of somebody who's really productive. They've got papers. They also have some reviews, but they have papers. They have a series of papers, not 6 papers a year in a intense scientific field. But I think people definitely want to see the quality. They want to see what journals you published in. What, again, whether you own the field. If you're writing the reviews on this area in the field, that's okay. But if you're then writing in a review of something completely different, and you now have a whole series of reviews that you've done, that's not going to impress people very much.
Kind of a shift. What do you think about traditional journals? How do you think they're adapting to rapid turnaround that open access journals can provide? Do you think this will impact the practices of traditional journals? And an example is given as such rapid turnaround for pandemic-related articles that we've recently seen.
I think the pandemic related articles really did have extraordinarily rapid turnover. I don't know that the open access model has really increased the rate at which papers are reviewed. I've not been impressed that the wait time is that much less. Unless it's one of those predatory journals where you submit it and they send you a bill, and that's that's your review process. You, speaking as a journal editor, you were totally at the mercy of your reviewers. And while we push to get people to give very rapid reviews so that we can get things back to people, it's often difficult. So I don't know. I don't know that those open access journals have really transformed the field, nor will they. I think some of the other things, and I'm not quite sure of the value of this. I know in the frontiers journals, frequently they will publish the reviews and the responses and the further responses to those responses. That will all be open access, if you will. I'm not sure that I don't like participating at that level. I don't necessarily, I don't often read those critiques, and if I have a critique of a paper, it's because I've come up with it or somebody I know who's read it has come up with it.
Okay. Also, kind of another shift in this question. How do you go about conducting clinical research that is truly impactful and adds value to the practice of medicine? Does this come with increased exposure and time in medicine?
Well, if you think about it, so if you want to be doing the definitive paper on, procedure X or approach to therapy Y, it's going to be a multi-center trial, and nobody is going to give an untried investigator the funds to do that. Those are expensive studies to do. So again, this is an area that I don't work in, so I'm not totally familiar on all the steps that you need to take to get to the point where people do trust you, that you'll complete the study, that it will be done appropriately, etc. But I've had the opportunity of watching a master, my co-director of the CTSI here, Judy Hockman, is a trialist, and that's what she thinks about. It's what she does from day to day, and it is interesting to watch as she organizes that sort of thing. So I think it requires certain skills, but again, she was not. She obviously couldn't have, immediately. I think her latest, the study that's still going is an $80 million study over many years of medical versus invasive therapy of coronary artery disease. And they wouldn't give that money to me because I don't have a track record of doing that kind of study, and they wouldn't give it to a neophyte either. But certainly, people that she's brought along with her have taken increasing responsibility for the conduct of those studies. And as you continue in those studies, people do figure out who can do this sort of thing. It's difficult to break into. I don't know all the ins and outs. Certainly on the other side of things, I think I understand things better.
Great. So that's all the questions I have in the Q&A. So I wanted to ask you a question though, as your experience as a journal editor, like what are the top 3 like take-home points you would want people to take with them today?
Oh, yeah. Make sure that you have an interesting paper, something that that I would want to read. Make sure that the title really tells people what you want to tell them, what your take-home message is. And, if do not, you shouldn't feel badly about getting help writing a paper, whether it's from colleagues or you can pay a copywriter or copy editor to go through your attempt at writing and turn it into English that is more standard, because all the most of the journals are in English. So I guess those are the main things that attract paper. That it's well written, that I understand what they're trying to say, that I can get through their abstract and have some sense of what they're trying to do. And I may not really fully understand the place of this science in the world of science, but I should have some idea.
Great. Well, I just want to thank you again, Dr. Kronstein, for your wonderful talk. And also, audience, I wanted to thank you all for your great participation in the Q&A. So again, I just want to finish by acknowledging the support of the sponsor for this session, the AFMR. And then I hope you guys will all come back for our next pre-conference session at 2 this afternoon, Common Statistical Errors. So thank you, everyone.
I think I've made those errors.